today's video we're going to take another look at the Rolls dictation machine. I had a communication from a viewer who also has one of these, and theirs is playing up. The magnetic film advancing mechanism here isn't working properly, and they've got many reels of the magnetic tape that they're trying to archive, so they'd like some help trying to get the machine working. They've given me a pretty good description of the problems they're having, so I'm going to take my machine apart and see if I can point out a few of the things that might be causing their issues. So we'll start off by taking the back section off here. That simply unclips as it did in the previous video, and the battery box just unplugs like this. In theory, like that, there we go. And then I'll flip it over and get the screws on the underside undone. So there's a handful of screws to take out to actually release the unit from the case. And then there's a screw at the front here that releases the front edge of the aluminium upper cover. And then there's a couple more at the back here, just in front of these relays, that need to come out as well. Then lift the bridge section up just to give some clearance, and wriggle that section off like that. So for a quick recap of how the machine should be working, I'll put this into play, and you'll now see the playhead is moving backwards and forwards, and each time it gets to the end of its throw it advances this wheel here, which actually drives the recording film forwards one notch. But what's happening with their machine? The head moves across to the left, okay, advances the film, then moves back to the right, and then it doesn't advance the film, and they're having to manually click it on one to actually advance the film. I've actually put a bit of paper to blank off the contact on this side, so I should be able to imitate what's happening with their machine. So it just stops at this side, and you have to advance that to get it to go back. So they're going through hours and hours of recording film like this, having to manually advance it, which is a bit painstaking. So now we'll have a look at the machine and look at all the components that actually make this film advance motor work, and see if we can give them some suggestions at what might be wrong with their machine. Oh, and a little note, if you're running one of these with the bridge section open like that when you haven't got the covers on, the guillotine part here needs to be taped out of the way, otherwise if I don't have the tape on, it fouls these two wheels here and the machine won't run at all. So looking at the movable playhead section, there are a couple of wires that run up the playhead. The gold multi-core wire goes to the actual playhead to deal with the audio, and the green single core wire goes all the way to the tip of the section to a copper plate that makes contact with a contact at the side of the machine, which advances the film advance motor one click. It's clear then that the green wire is okay because it's working on one side, just not on the return side, so it's something else that's the problem. The electrical contact that the copper plate at the end of the playhead hits is this little spring-loaded brass pin in here that I'm just prodding. There's one of those on each side of the machine, and each of those pins is wired to a relay at the back of the machine that switches the power to the film advancing motor. The film advancing motor is quite high power, sort of somewhere around 0.5 amp, so it needs the relays to actually handle that current. The relays are at the back of the machine here and one over this side. Interestingly enough, the one on the right hand side here is wired to the contact on the left hand side of the machine, and the one on the left hand side of the machine is wired to the contact on the right hand side. The film advancing motor itself is here. It's some sort of stepper motor, and it's a little temperamental even on my machine. It will move one click each time one of the relays at the back closes, or at least it should do. The springy brass plate here has a ball bearing in it, which sits in the holes located round the wheel. This seems to have two jobs. Its first job is to make sure the motor stops at the right place. It's quite critical with this motor that it's in the right place so it runs in the right direction. If it's sitting slightly behind where it should be, the motor will actually run backwards, so the ball bearing locates it in the right place. The springy brass plate with the ball bearing also puts the motor into the right position when you want to rewind it. When you hold the rewind button on the remote control, this solenoid here will close, and that moves the springy brass plate, which in turn moves the motor backwards slightly, so it's in the right position in relation to the field windings of the motor that it'll turn backwards. So if I close this solenoid now with my finger, you'll see the motor will just move backwards a little bit, like that. It's not much, but that's just enough to make the motor kick backwards rather than forwards. And finally, on the other side of the machine, you've got the two notched wheels here that operate the two switches beneath them. Those switches supply the power to the two solenoids here. These solenoids move the friction plate that changes the direction of the playhead. So, to try to diagnose the problem with the other Rolls machine, first we need to see if these two relays are moving correctly. I've put a bit of paper in the contact on this side of my machine again to simulate the fault they're having. So when the head gets to this side, this relay should move, but at the moment that's not happening because of my bit of paper. So if I put it into play, the head will go to this side and then come back correctly, and when it gets here it just stops. When the relay is moving correctly, it should look like this. If this relay isn't moving as it should be, it's likely to be either the contact beneath this panel that the head touches isn't making good contact, or the wiring between that contact and the relay isn't correct, or the relay itself has gone wrong. So, assuming the relay isn't moving as it should be, the first thing to do would be to clean the contact and make sure it's making a good connection. And I've cut myself here a little bit of card that I can insert through the gap between the top plate and the roll holder part on the machine, so I can get it in front of the contact. Then I can move the head across so it's pressing itself against the contact with the card in the way, and I could dampen my bit of card with methylated spirits or something like that, and then just jiggle it backwards and forwards to try and clean up the contact. Worst case, if I really thought the contact was dirty, I could stick a bit of very fine wet and dry paper, say 1200 grit, to my bit of card to actually clean any dirt off the surface of the contact. Once the contacts have been cleaned and checked, if one of the relays still isn't moving correctly, the next thing to do would be to check the relays themselves. This can be done quite simply because they're identical relays, and this springy clip on the top just pulls to one side, and you can pluck the relay out like that and swap it for the other one. I'd be inclined to mark the relays which one's which before you start swapping around, in case for some reason they don't work swapped over, but I've tried swapping mine and it works fine having swapped them. The Rolls machine that isn't working did used to work, so I'm kind of hoping that the wiring is all intact. So we won't look at trying to trace a wiring fault at the moment, we'll look for other problems. So next, if both of the relays are actually moving correctly, the problem could be that the contacts on one of the relays are dirty and not making good electrical connection. That could be simply checked by swapping the relays over as we previously described. The motor could be tight or binding, Without the power to the machine, the motor should feel notchy because you've got the spring-loaded ball bearing here. You've also got the two notched wheels on the far side of the machine, and also the magnets of the motor itself make it feel notchy. So it'll feel notchy, but it should be fairly free to turn, and it shouldn't have a tight spot anywhere on the rotation. But I suspect the most likely cause of the problem is that the motor isn't quite adjusted right in its resting position. It is really quite a temperamental little device, and there is a bit of a way to fine-tune it, which we can look at in a minute. Assuming one of these machines hasn't been tampered with, it should be more or less as it came out of the factory, and with a bit of luck it should only need some fine-tuning. The little section here that moves to put it into its reverse position has an adjuster just behind this set of switches above the solenoid, and beneath the spring here there is an adjusting screw. It's a little tricky to get at, so we'll change to a different camera angle and see if we can have a look at it. I probably need to explain more or less how this motor works to understand why this adjustment is so critical. Behind this plastic wheel there is a ring magnet which appears to have multiple north and south poles. And then behind that is the electromagnet with its static poles. You can see the poles here, and you can see the copper windings of the electromagnet. If one of the north poles of the ring magnet is directly above the north pole of the electromagnet, when the electromagnet is energised, it'll repel that north pole of the ring magnet, but if it's directly on top, it'll just try to push it outwards and the motor won't move at all. But if the north pole of the ring magnet is very slightly ahead of the north pole of the electromagnet, when the electromagnet is energised, it'll repel or push the ring magnet forwards one notch. If, on the other hand, the north pole of the ring magnet is sitting slightly behind the north pole of the electromagnet, when the electromagnet is energised, it will repel or push the ring magnet backwards one notch. So you can see that the parking position of this wheel is really critical for the motor to actually work correctly. So looking more or less from above the machine, you've got the wheel of the motor here, and this is the movable plate that puts it into the reverse position. And you've got the spring here that is the return spring for that movable plate. And if I move that to one side, just down here you can see an adjuster screw with a nut. And that's the fine-tuning adjustment for the rest position of the motor. I've now inserted a very thin sheet of card which goes underneath that adjusting screw, so in essence the adjusting screw is now set too long. And if I put the machine on to play, you'll see it's sticking at the end, and I just have to tap the wheel to get it to actually work. Occasionally like that it'll work, and then occasionally it'll stick, and that's just that teeny bit of card making that adjusting screw too long. I've now got a slightly thicker bit of card inserted, so in other words it's the same as having this screw adjusted slightly longer. And when I switch the machine on now, you'll actually see that the advance motor works backwards. And that bit of card is only about the equivalent of one turn of the screw, so it really is quite a fine adjustment there to get it right. The easiest way I found to adjust this screw is first to remove the return spring. I've got some fine tweezers that I can just grab the loop of the spring and unhook it to get that out of the way. And then I'll need a fine screwdriver and a pair of pliers just to undo the nut. Oh yes, and I forgot that when my machine first arrived, the nut and adjusting screw were covered in thread lock, because you're not meant to adjust those, but mine needed some tweaking, so I had to chip that off carefully. You need to expose the slot in the screw to be able to adjust it. So first things first, just need to unlock the lock nut. You could do it with a very small socket, or you could do it with pliers. I can't remember how tight this was initially. Anyway, that's unlocked. And then to shorten the screw a little bit, which will in essence advance where the ring magnet is in relation to the static north poles, you just insert the screwdriver and turn the screw backwards, let's say quarter of a turn. Oops. And then re-lock the lock nut. Don't do it too tight, particularly at the moment, because you're going to be having to probably adjust this a few more times. And then it's a case of using your fine tweezers again to re-hook the spring onto its hole. Which is kind of, there we go, it's back on, right. And so now we can test that again, which of course now mine will be set wrong because it was set right before. But let's see how it runs now. Okay, let's see, I've put the power back on, so let's see if mine's still working. Yeah, that quarter turn hasn't ruined mine. Let's see if it still reverses. Okay, yeah, reverse is a bit temperamental because I am probably slightly too advanced now. So I'll set that quarter turn back to put mine back where it was. But you get the gist of that, how to adjust that adjuster. This video has gone on far too long, so I'm going to save the rest for part 2. In the next instalment I'll take the stepper motor apart and show what I had to do to repair it. I'll put a link to that video in the description. If you've enjoyed watching, feel free to like the video and subscribe to the channel. There'll be more vintage stuff and repairs coming soon. So thanks for watching, and I'll see you in a future video.